Alrighty, boys and girls, welcome back. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And this is similar to the notes that we had before, but I want to be able to do some, call that quick math, without a calculator. So, again, you want to be able to have your perfect squares and be able to multiply against the 2 is in the exponent. Again, you're doing 19 times 19, and so you are doing a perfect square. So again, you're ending up with that result of 361. You get 256, 169, 11 times 11 is 121. And using that same skill, maybe the square root of 121 is 11. So again, you want to be able to know up to, so know perfect, let's say we want to be able to know perfect squares from 0 to 20. So that way, again, the less time you spend using that calculator, the less time you have to calculate anything, and you can rely on yourself as opposed to anyone else. So as I fill these in, again, a lot of them you can use your context clues for yourself. Alright, so a quick refresher from yesterday's notes. Again, the Pythagorean Theorem, make sure that you're getting that pronunciation correct, is the equation a squared plus b squared, again to the second power, equals c squared, where a and b are legs and c is the hypotenuse. Hypotenuse. Make sure you're getting that pronunciation. Again, these two are the tougher ones to say, but as long as you are sounding it out, you will sound correct. So the legs and the hypotenuse of a right triangle. So, triangle, let me spell that one right. We must have that C is the largest value or the longest side. So if you're looking at a set of numbers, it would be the largest value. If you're looking at a picture of a right triangle, it's going to be that longest side. We need to have that where C is the hypotenuse for us to use that Pythagorean theorem. Alright, so underneath of that I have those expectations. So this is under that essential knowledge. So you must be able to determine whether a triangle is a right triangle given these three sides. So these sets of whole numbers where the side lengths form a right triangle are called Pythagorean triples, because you can have three numbers that when you take the sum of the two legs squared, it will equal the hypotenuse squared. So let's see. Just like yesterday, you want to be able to identify, given three numbers, any three numbers, you know that for sure the, what do we say, the largest value is going to definitely be the hypotenuse. So, again, I can circle 5 because out of these three numbers, 5 is going to be the hypotenuse. Okay? Again, it says to write the equation first, and so we're going to do a squared plus b squared equals c squared. We're going to plug in our values for our variables, and we're saying, hey, does this work? Does this equation hold a true statement? So again, a and b, it doesn't matter as long as you know for sure that the largest is the hypotenuse and the others are the legs. So let's do, to change it up, we can do 4 squared plus 3 squared. Does that equal 5 squared? Well, you simplify very carefully and you say 16 plus 9. Does that equal 25? Well, does 25 equal 25? Yes, it does. So you say yes for this one. And since we got a good result, we are happy about that. Again, identify the largest value, that's the hypotenuse. Write your equation and plug in your values for your variables. You want to be able to do this consistently so that way you can recall it at any time. It's just like practicing anything else. As long as you are, get that little bit of repetition, you'll be good to go. All right, so we got 36 plus 64 equals 100. Is this true? Well, let's see, 100 equals 100, and I know for sure that is true, and so we are still good. Let me actually, before I even do that, let's say yes, it is a right triangle. Okay, last couple. Okay, so let's see. We got 9, 12, and 15. So which one is the largest? Well, it's not necessarily the last number each time, right? It has to be the one that is largest out of those three. And I'll show you that in a second as well. So let's see. We know that 15 is going to be a hypotenuse. And so now we have that this is going to be a squared plus b squared equals c squared. All right, so plug in our values for a variable. So we got 9 squared plus 12 squared equals 15 squared. Is this a true statement? Let's find out. 81 plus 144. Got to know those. You know what that's called? Quick math. 81 plus 144. Does that equal 225? Well, let's find out. 225 does, in fact, equal 225. And so, yes, this is also a right. Oh, man. Let's be able to spell. This is also a right triangle. So, again, make sure that if you need to, you can pause at any point, replay, instant review, all that stuff. So, again, last set of numbers, which one is the hypotenuse? Because we're looking to see, is this a right triangle? 20 is our hypotenuse since it is the largest of these three values. And so again, a squared plus b squared equals c squared. Plug in those values for your variables. So we have, let's say 12 squared is going to be added to 16 squared equals 20 squared. Alright, so you know that for sure that is going to be a right triangle since, again, we're looking to make sure that's a true statement, and so we're good. And so now, last question on this. What kind of pattern do you notice about these numbers? Well, if you look at this first set of triples, you see that's 3, 4, 5. Okay. What about 6, 8, and 10? Well, if we multiplied 2 to each of these values, we would know that it would be another multiple of it. So each of these sets of numbers are multiples of the original. So we can say they are multiples of each other. If you get to know some of these Pythagorean triples, that way, you get real quick with those values, you'll be good to go. So now flip it to the back. So if I have these values, so it says a different expectation, determine the measure of a side given 2 of the other sides. So first case, given 2 legs, oh boy, given 2 legs, what is the hypotenuse? So again, a squared plus b squared equals c squared. Plug in those values. These are legs, so again, these are legs, and we're looking for the hypotenuse. So we're going to have, again, 9 squared plus 12 squared equals c squared. Again, we're looking looking for C. All right, so we're going to do 81 plus 144 equals C squared. We have 225 equals C squared. Make sure you do the inverse operation. So we're taking the square root of both sides. And so now we have 15 equals C. So that side length is C. I want you to try the next one, and then I'll show you a second case. So the second case is, given the hypotenuse, what is the other side length? So we're going to have A squared plus B squared equals C squared. 13 squared and 5 squared. We're going to add that to a side length squared. So we're going to have A squared plus